Section 3.5, Solving Equations Involving Integers 2. In this video, we will see how to solve advanced equations with combining like terms, the distributive property, variables on both sides of the equation, and variables multiplied by -1. We return to solving equations involving integers, only this time the equations will be a bit more advanced, requiring the use of the distributive property and skill at combining like terms. Let's begin. Example 1. Example 1. Solve for x in the equation 7x minus 11x equals 12. Solution, combine like terms. 7x minus 11x is -4x. So now we have the equation -4x equals 12, and to undo the effect of multiplying by -4, we'll divide both sides by -4 to get x equals -3. We'll check this solution by substituting -3 for x in the original equation, 7x minus 11x equals 12. So letting x equal -3, we get 7 times -3 minus 11 times -3 equals 12. Then 7 times the -3 is -21, and 11 times the -3 is plus 33. And -21 plus 33 equals 12. Because the last line of the check is a true statement, 12 equals 12, -3 is a solution of the original equation. Example 2. Solve for x in the equation 12 equals 5x minus 4 plus x. Solution. To take the negative of sum, negate each term in the sum, change each term to its opposite. Thus -4 plus x equals -4 minus x. So the original equation becomes 12 equals 5x minus 4 minus x. Then, combining like terms, 5x minus x is 4x, so we get 12 equals 4x minus 4. To undo the effect of subtracting 4, we'll add 4 to both sides of the equation to get 16 equals 4x. Then, to undo the effect of multiplying by 4, we'll divide both sides by 4 to get 4 equals x. To check this, we'll substitute 4 for x in the original equation to get 12 equals 5 times 4 minus the sum of 4 and 4. Simplifying within parentheses first, we get 4 plus 4 is 8. Then multiplying, we have 5 times 4 is 20. Then subtracting 20 minus 8 is 12. Since both sides are equal, a true statement, 4 is indeed a solution of the original equation. Variables on both sides. Variables can occur on both sides of the equation. Goal: isolate the terms containing the variable you are solving for on one side of the equation. Example 3. Solve for x in the equation 5x equals 3x minus 18. Solution: to isolate the variables on one side of the equation, subtract 3x from both sides of the equation, and simplify. Subtracting 3x on both sides, we get 5x minus 3x equals 3x minus 18 minus 3x. We combine like terms, 5x minus 3x is 2x, and 3x minus 3x is 0. So we're left with 2x on the left side, and -18 on the right side. Note that the variable is now isolated on the left-hand side of the equation. To undo the effect of multiplying by 2, we'll divide both sides of the last equation by 2, so we get x equals -9. Checking, we let x be -9 in the original equation to get 5 times -9 on the left-hand side, and 3 times -9 minus 18 on the right-hand side. Then on the left-hand side, 5 times -9 is -45, and on the right, 3 times -9 is -27, and on the right-hand side, -27 minus 18 is -45. Since the last line is a true statement, -9 is indeed a solution of the original equation. Example 4. Solve for x in the equation 5x equals 3 plus 6x. Solution: to isolate the variable on one side of the equation, subtract 6x from both sides of the equation and simplify. On the left-hand side, we have 5x minus 6x, and on the right-hand side, 3 plus 6x minus 6x. 6x minus 6x on the right-hand side is just 0, and on the left-hand side, 5x minus 6x is -x. So we're left with -x equals 3. Note that the variable is now isolated on the left-hand side of the equation. There are a couple of ways we can finish the solution. Remember, -x is the same as -1x, so we could undo the effects of multiplying by -1 by dividing both sides of the equation by -1. Multiplying both sides of the equation by -1 will work equally as well. But perhaps the easiest way to proceed is simply negate both sides of the equation. Negating -x, we get negative times -x is a positive x, and negating positive 3, we get -3. So x equals -3. To check this, we substitute -3 for x in the original equation to get 5 times -3 equals 3 plus 6 times -3. And on the left-hand side, 5 times -3 is -15, and on the right-hand side, 6 times -3 is -18, and 3 minus 18 is -15. Because the last line of the check is a true statement, -3 is the solution of the original equation. Dealing with -x. If your equation has the form -x equals c, where c is some integer, note that this is equivalent to the equation -1 times x equals c. Therefore, dividing both sides by -1 will produce a solution for x. Multiplying both sides by -1 works equally as well. However, perhaps the easiest thing to do is to just negate each side, producing negative x equals negative c, which is equivalent to positive x equals negative c. Example 5. Solve for x in the equation 6x minus 5 equals 12x plus 19. Solution. To isolate the variables on one side of the equation, subtract 12x from both sides of the equation and simplify. So subtracting 12x from both sides, we get negative 6x minus 5 on the left-hand side and 19 on the right-hand side. Note that the variable is now isolated on the left-hand side of the equation. Next, to undo subtracting 5, add 5 to both sides of the equation. On the left-hand side, we get negative 6x, and on the right-hand side, 24. Finally, to undo multiplying by negative 6, divide both sides of the equation by negative 6. So on the left-hand side, we're left with x, and on the right-hand side, 24 divided by negative 6 is negative 4. So x equals negative 4. Check by substituting negative 4 for x in the original equation. Letting x equal negative 4, we get 6 times negative 4 minus 5 equals 12 times negative 4 plus 19. On the left-hand side, 6 times negative 4 is negative 24, and negative 24 minus 5 equals negative 29. On the right-hand side, 12 times negative 4 is negative 48, and negative 48 plus 19 is negative 29. Because the last line of the check is a true statement, negative 4 is indeed a solution of the original equation. Example 6. Solve for x in the equation 2 times the sum of 3x and 2 minus 3 times the difference of 4 and x equals x plus 8. Solution. Use the distributive property to remove parentheses on the left-hand side of the equation. Distributing the 2 first, we get 2 times 3x is 6x, and 2 times plus 2 is plus 4. Then, distributing the 3, negative 3 times a positive 4 is negative 12, and negative 3 times a negative x is positive 3x. Now, we will combine like terms to simplify the left-hand side. 6x plus 3x is 9x, and 4 minus 12 is negative 8. Leaving us with the equation 9x minus 8 equals x plus 8. We need to isolate the variables on the left by subtracting x from both sides of the equation. So on the left-hand side, we get 9x minus 8 minus x equals 8x minus 8, and on the right-hand side, we get x plus 8 minus x equals 8. Note that the variable is now isolated on the left-hand side of the equation. To undo subtracting 8, we'll add 8 to both sides of the equation. So we get 8x minus 8 plus 8 on the left-hand side, which equals 8x. And on the right-hand side, we get 8 plus 8, which equals 16. Finally, to undo multiplying by 8, we'll divide both sides of the equation by 8. So on the left-hand side, we have 8x divided by 8 is x. And 16 on the right-hand side divided by 8 is 2. So x equals 2. We'll check 2 by substituting it for x in the original equation, which was 2 times the sum of 3x plus 2 minus 3 times the difference of 4 and x equals x plus 8. So letting x equal 2, we get 2 times the product of 3 and 2 plus 2, and negative 3 times the difference of 4 and 2 equals 2 plus 8. Simplifying within parentheses first, the product of 3 and 2 is 6, and 6 is plus 2 on the left-hand side is 8, and 4 minus 2 is 2. Then 2 times 8 is 16, and 3 times 2 is 6. Then 16 minus 6 is 10. On the right-hand side, 2 plus 8 is 10. Since both sides are equal, a true statement, 2 is the solution of the original equation.